How many moons does Earth have? 1. You learn this in school. Every diagram shows one moon orbiting one Earth. Every textbook confirms it. Jupiter has 95 moons. Saturn has 146. Earth has 1. Except that is not quite true. Right now, as you watch this, there are at least 7 objects sharing Earth's orbital neighborhood. Rocks ranging from the size of a building to the size of a bus, traveling alongside our planet. Some of them for decades, some for centuries. One of them was only discovered last year. Another has been following Earth since before the first human walked on the moon. And one of them, the most extraordinary of all, appears to be a piece of the moon itself, blasted off the lunar surface by an ancient impact millions of years ago, and now orbiting the sun in near perfect synchronization with Earth, a fragment of our own moon, following us through space. And in 2 months, a Chinese spacecraft is going to land on it, collect samples, and bring them back to Earth. This video is about the objects you were never told about, the hidden companions that travel alongside Earth through space. We'll explain the difference between quasi-moons and mini-moons, because they are not the same thing, and the distinction matters. The newest one, discovered in August 2025, a 19-meter rock called 2025 PN7 that has been silently accompanying Earth since the 1960s, before humans first set foot on the moon, and nobody noticed. The mini-moon that actually orbited Earth for 2 months in 2024, before breaking free and returning to its own path around the sun. Then Kamo'oalewa, a boulder-sized object discovered in 2016. That scientists now believe is a fragment of the moon, ejected from a lunar crater by an impact between 1 and 10 million years ago. It has been following Earth ever since. A Chinese spacecraft called Tianwen-2 launched in May 2025 and will arrive at Kamo'oalewa in July 2026 to collect a sample and bring it back. If the sample confirms the spectroscopy, it will be the first time humanity has retrieved a piece of the moon without going to the moon. And finally, how many of these companions are out there that we have not found yet? The answer, according to computer models, is far more than you expect. First, let's be precise about what these objects are and what they are not. A moon, a true natural satellite, orbits a planet. It is gravitationally bound. Our moon orbits Earth. Phobos orbits Mars. Europa orbits Jupiter. They are locked in by gravity. A quasi-moon is something different. A quasi-moon orbits the sun, not Earth. It travels on its own independent path around the sun. But that path happens to be so similar to Earth's path. From our perspective, it appears to orbit us. Imagine 2 runners on a circular track. They are both running around the track independently. Neither is following the other. But one runner is slightly faster and the other slightly slower. Sometimes the faster one is ahead, sometimes the slower one catches up. From a helicopter above, they look like they are circling each other, but they are both just running the same track at slightly different speeds. That is a quasi-moon. It orbits the sun. Earth orbits the sun. Their orbits are so similar that the quasi-moon appears to loop around Earth, sometimes closer, sometimes farther, in a slow cosmic dance that can last decades or centuries. One astronomer described it as a wolf following a band of prehistoric hunters, keeping company. Traveling the same path, close enough to seem like part of the group, but never truly joining. As of 2026, astronomers have identified 7 confirmed quasi-satellites of Earth. 7 rocks ranging from 19 meters to roughly 100 meters across, all orbiting the sun on paths so similar to ours that they appear to accompany us through space. The most stable is Kamo'oalewa, discovered in 2016. It has been Earth's companion for at least a century, and will remain so for centuries more. The newest is 2025 PN7, discovered in August 2025. But archival data revealed that it has been in its current Earth-accompanying orbit since the mid-1960s. It arrived before humans landed on the moon, and nobody noticed until 6 decades later. These are not rare anomalies. They are a normal feature of orbital mechanics. Any planet will accumulate co-orbital companions through the gravitational interplay between the planet and the star. Venus has quasi-moons. Mars has quasi-moons. Earth has at least 7 that we know of. The question is not whether they exist. The question is how many more are out there that we have not yet detected, because most of them are small and dark. 2025 PN7 was first observed on August 2, 2025 by the Pan-STARRS telescope in Hawaii, specifically designed to scan for faint, fast-moving objects. The asteroid is roughly 19 meters across, about the size of a building, and orbits the Sun at nearly the same distance as Earth, with an orbital period almost identical to ours. Its orbit is slightly oval, so sometimes it is closer to the Sun than Earth, and sometimes it is farther. This difference creates the looping pattern. From Earth's perspective, 2025 PN7 appears to circle us, sometimes within 299,000 kilometers, roughly the distance to our moon, and sometimes drifting tens of millions of kilometers away. It is extraordinarily dim, magnitude 26, far too faint for any amateur telescope. Researchers estimate it synced into orbit around 1957, the same year the Soviet Union launched Sputnik. While the world celebrated putting the first object into orbit, a natural object had already been quietly orbiting alongside Earth for decades. And it will continue to do so until roughly 2083, when gravitational perturbations will shift it into a horseshoe orbit, and it will slowly drift away. It was here before the space age started. It will leave before the century ends. And for 60 years, nobody knew. Quasi-moons orbit the Sun alongside Earth. They are companions, but not captives. Mini-moons are different. Mini-moons are objects that Earth actually captures, temporarily snared by our planet's gravity, pulled into genuine orbit around Earth for weeks or months before breaking free and returning to solar orbit. Think of it this way. A quasi-moon is a wolf following the camp. A mini-moon is a stray dog that wanders into the camp, stays for a while, and then leaves. In late 2024, an asteroid designated 2024 PT5, roughly the size of a school bus, was temporarily captured. For 2 months, it was a genuine natural satellite. Earth briefly had 2 moons. Then, the object's orbit destabilized, the Sun's gravity reclaimed it, and it drifted back into its own solar orbit. Astronomers have only confirmed 4 mini-moons in history. The first was 2006 RH120. The second was 2020 CD3, captured for roughly 2 years. But computer models suggest these are just the tip of a much larger phenomenon. Simulations predict that at any given time, there should be at least 1 natural satellite. Not might be, should be. Right now, statistically, there is almost certainly a rock orbiting Earth that we have not found, a gravitational game of catch. And then there is Kamo'oalewa. Of all the objects in Earth's orbital neighborhood, Kamo'oalewa is the most extraordinary, and the reason involves our moon. Kamo'oalewa was discovered in 2016 by the Pan-STARRS telescope. It is 40 to 60 meters across. It spins extremely fast, 1 full rotation every 28 minutes. And it orbits the Sun in near-perfect synchronization with Earth, looping as close as 38 times the distance to the Moon. Its name means oscillating celestial fragment. Fragment. That word turned out to be prophetic. When astronomers pointed spectrometers at Kamo'oalewa, they found something unexpected. It matches the Moon. In 2021, a team published the first spectroscopic analysis. The reflectance spectrum showed an extremely reddened silicate signature, a hallmark of space weathering. And the specific pattern matched one material better than any other: space-weathered lunar soil. They compared it against samples from Apollo 14 and Chang'e 5. The match was striking. Researchers identified the most likely source: the Giordano Bruno crater, a 22-kilometer impact crater on the far side of the Moon. The impact occurred between 1 and 10 million years ago. It was violent enough to blast fragments of lunar crust clear, and one fragment settled into a solar orbit, keeping it perpetually close to Earth. A piece of the moon, broken off by an ancient impact, has been following us for millions of years. It is accompanying Earth. Think about what this means. A piece of the moon, the same moon that controls our tides and stabilizes our axial tilt, was broken off and launched into space, and through gravitational dynamics alone, found its way into an orbit that keeps it close to Earth. Kamo'oalewa is the most stable quasi-satellite Earth has. It will remain there for centuries more. It is loyal to Earth because it originated from the Earth-Moon system itself. It didn't wander in, it was born here. It is a piece of home, and it has been traveling alongside us undetected since before our species existed. We found it in 2016. It was always there. In May 2025, the China National Space Administration launched a spacecraft called Tianwen-2. Its primary target, Kamo'oalewa, arriving July 2026. No spacecraft has ever visited an object this small that rotates this fast. Landing on it will require precision that no previous asteroid mission has attempted. Tianwen-2 will escort Kamo'oalewa for several months, mapping its surface. Then it will deploy a lander to collect samples directly from the surface. The samples will be returned to Earth in 2027. If Kamo'oalewa is a fragment of the moon, those samples will be lunar material retrieved without a lunar mission. The scientific value is immense. It would provide a unique record of space weathering processes that cannot be studied from samples on the lunar surface. But the emotional value may be greater. If confirmed, it would be proof that the moon is not just our companion. Pieces of it are scattered through our neighborhood. We know of 7 quasi-satellites and 4 confirmed mini-moons, but the actual number of objects in Earth's orbital neighborhood is almost certainly far larger. Simulations predict that at any given moment, there should be at least one natural satellite of 1 meter or larger, a gravitational conveyor belt. Most are too small and faint to detect, but the Vera C. Rubin Observatory, which began taking data in 2025, is designed to scan the entire visible sky. It is expected to discover hundreds of new near-Earth objects per year. The picture of Earth's orbital neighborhood is about to get much more crowded. The textbook diagram was always a simplification. Earth is not alone with one companion. It travels through a shifting, invisible constellation of rocks. Earth is the only planet with just one large natural satellite. Mars has 2. Jupiter has 95. Saturn has 146. Earth has the moon, singular and enormous. It has defined human culture and mythology for all of history. And for all of that history, we thought it was alone up there. It is not. Earth travels through space, accompanied by a shifting entourage of small, dark, silent objects. Some captured, some keeping pace. Fragments of the moon itself. We did not know about them until 1997. Kamo'oalewa was found in 2016. A spacecraft launched last year is on its way to find out. The answer matters. The textbook version of Earth is a solitary planet in empty space. The reality is that Earth is surrounded by companions we are only now learning to see. Some are temporary. Some have been with us for millions of years. And the one that may be a piece of our moon, it stays close, as if it remembers where it came from.